experts in the biology of hair and the stem cells that exist in all of us that give rise to our hair growth and the pigmentation in our hair, and in talking to experts who understand how to halt and even reverse hair loss, that there is a tremendously interesting biology surrounding hair. But there's also an incredible psychology around hair. In fact, most people who experience even marginal hair loss undergo pretty severe anxiety. Now, I confess this is not something I can relate to. I am losing my hair in certain places. I'm 47 years old. I've got a couple of patches up front where there's very minimal hair. I think that, as we'll later learn in this episode, reflects a higher density of DHT, dihydrotestosterone receptors at that particular location as opposed to elsewhere on my scalp. But keeping my hair is not something that I've fretted about much of my life. And yet, as I was researching this episode, I remembered an anecdote from my childhood where my father told me, and I think it was because was stressing about something, and I was trying to get to sleep. And he said, "Don't stress, calm down. And here's why. If you stress too much, it can actually make your hair fall out. In fact, I have a cousin who lay down one night stressed and woke up the next morning and all of his hair was on his pillow." And I'll never forget that story. I think he was trying to get me to stress less. I don't know if that story made me stress less or not. But in any event, I don't know that that story is true. I'm not going to challenge the authenticity of that story. I didn't have a chance to reach out to my father and ask him to verify or not. But as we'll soon learn, it is true that our psychological well-being can impact both the coloration or lack thereof and the growth rates of our hair. That's a real thing. And the reverse is also true, which is that as hair starts to thin or fall out or change color, many people experience intense anxiety or even depression. This was not something I was really aware of. And perhaps that's just because I've always kept my hair pretty short anyway. I always assumed that if my hair started to really fall out, I would just shave my head. But that's me, and that's not most people out there. I think most people would loathe to lose their hair. And in fact, given the enormous number, probably up in the high billions of dollars and euros and other currency, of course, that people invest in trying to halt or reverse their hair loss, it's clear that hair is very, very important to people. What we know is that by age 50, approximately 50% of all men and women will have experienced significant enough hair loss that they start to notice it. And a large percentage, up to 85% of those people, will experience some sort of anxiety that leads them to go out and try and either halt or reverse that hair loss. Now, why at age 50? Well, an important point arises from that, which is that the hair loss is not occurring between the 49th and 50th birthday. Hair loss is ongoing from about age 30 to age 50. It's only by age 50, however, that about 50% of people out there start to notice that hair loss. And this is typically because they'll be in a bathroom or looking in a mirror, and the lighting will be bright enough that it permeates the sort of outer boundary of their hair, and they'll notice that their hair is thinning in a particular location. That's usually how this sort of thing happens. So again, our psychological states can impact our patterns of hair growth or loss, and of course, patterns of hair growth, but more typically hair loss and hair graying, can really impact psychological states. So this is a subject that people take intense interest in. And today we're going to talk about how hair normally grows, why it grows at the rate and for the duration that it happens to. And then as we talk about ways to intervene with that hair loss, those biological mechanisms will come up because they really provide a nice framework for explaining why certain treatments work more or less well, or why certain treatments might have certain side effects or total lack of side effects. It will also highlight a really key theme that will come up several times in today's podcast, which is that there are both mechanical and chemical approaches to slowing and reversing hair loss. Mechanical approaches would be things as simple as massaging the scalp, but mechanical changes to the scalp can cause either hair loss or facilitate hair growth. This is why things like microneedling are so prominent in the context of trying to reverse hair loss. But again, there are also chemical approaches to trying to halt or reverse hair loss. And this relates to the fact that the hair growth itself is strongly regulated by hormones such as estrogen, thyroid hormone, insulin-like growth factor, and that other hormones, in particular the androgens, so things like testosterone, but mainly its derivatives like dihydrotestosterone, are very much involved in setting the stage for hair growth by controlling how big or small that pool of stem cells that gives rise to hair growth is. So if any of the terms I just used are confusing to you, don't worry. I will make all of those very clear in a moment. It's actually all pretty straightforward and simple. And so I'd like to just start by talking about what hair is, how it grows, why it stops growing, and why hair normally falls out. Let's talk about the biology of hair. And in doing so, I also want to talk about stem cells. Now, keep in mind that when you hear the word stem cells, you probably, like most people, think about the sorts of cells that people are getting injected into their face to get rid of wrinkles or give them new skin or to give them more hair if it's injected in the scalp or into a joint to repair a joint or a muscle. Those stem cells are what we call exogenous stem cells. Exogenous, meaning from outside the body. The stem cells that we're going to talk about today are so-called endogenous stem cells, cells that we all make that can give rise to other cells. And that's really the definition of a stem cell. Stem cells are present in all of us from the very beginning of life. So when sperm meets egg, that cell, which we think of as the egg, starts to duplicate. It incorporates the DNA from the sperm and the egg, of course. Starts to duplicate, and then those cells give rise to more cells and more cells, and the ability of all those cells to replicate and create more cells are because those cells really are stem cells. Now, at some point, we are a completed body plan, as the biologists say. We end up with a brain and a spinal cord and limbs and fingers and livers and guts and all the things that we need in order to be a functioning human being. Even though we're a baby at that time, we haven't grown up. We have all the bits that we're going to have for our entire life. At that point, many of the stem cell populations disappear. For instance, past puberty, and probably earlier, you don't get many more new brain cells. You get a few, but you don't get many more new brain cells because the brain doesn't have many stem cell populations, whereas other organs in your body maintain little pockets of stem cells, or in some cases, many, many stem cells that can give rise to more and more of that tissue across the lifespan. And hair is one such tissue. So if we take a look at hair, what we find is that indeed, there are these things that we call hairs, but there are also stem cells, and those stem cells are actually what give rise to the hairs that we see on the head of our scalp or that we see on the surface of our body. So right off the bat, you should know that every single hair that you have is there because you have a stem cell population that is giving rise to that particular hair. So let's take a step back. Or rather, I should say, let's zoom in on one hair and the stem cell population that gives rise to that hair. Because in doing so, you're going to learn all the different components that you can tap into if your goal is to halt the loss of hairs or to replace hairs that have already been lost. Okay, so if we were to just zoom in at the level of one hair, what you would find is that that hair has what typically is called a hair root. So that's the portion below the skin. And when we say below the skin, it means that it dives down into a narrow trench, which is in the so-called epidermis, which is this outer layer of skin. It also has a shaft. The shaft is the part that grows out above the skin. So what you see on somebody's head or you see on their arm, or when you see an eyebrow, you're seeing the shaft of the hair. The root, of course, goes below the skin. What most people don't realize, however, is that down at the base of the root, there's actually a little cave, a little pocket. So if you were to look at this, it would look like a little bulb, a little round area with a bunch of stuff in it right below the root. And within that little cave, there are stem cells. There are populations of cells that have the ability to divide. Right? We call this mitosis. It's a process by which cells can actually divide and take DNA with them and then give rise to other cells. We call those cells that divide and move out, we call those daughter cells. We call the cells that give rise to them progenitor cells. But they are effectively stem cells that give rise to these, what we call daughter cells. Those daughter cells then become the various types of cells that make up the hair. So when you see a hair, you're not seeing something that grows throughout the lifespan. You're seeing something that's going to be born down there in that little cave then is going to grow. It's actually going to stack up on top of itself. And that's because hairs are made up of a protein called keratin. There are a bunch of different kinds of keratins, depending on what kind of hair you're looking at. But these are little proteins that stack up on top of one another, and they're structured in a way that makes them pretty darn durable. I mean, it's possible, of course, to pull a hair out. But if you've ever tried to tear a hair, in particular, thick hair, like one from the face or even one off the top of your head, it's actually a pretty tensile, strong little thing. And that's because keratins stack up on top of one another and bind to one another with a really strong bond. So what you end up with is a bunch of proteins stacked up on top of one another, and that's the actual hair. Okay, so we've got the hair shaft, the hair root, and then we've got the stem cells down there in that pocket that give rise to the various cells that make up the actual hair. We also have down there in that little cave, which, by the way, is actually called the hair bulb, if you really want to know the technical name, because it's shaped like a bulb. We have not just stem cells, but we have cells that give rise to the pigment of the hair that create what's called melanin. Now, some people have very blonde hair, very light hair. Some people have darker hair. But everybody, unless they have what's called the albino mutation, where the hairs are truly white, they lack all melanin. And this is a pretty rare condition, although it does happen. Most people have some degree of melanin in their hairs because there are little pockets of melanin-producing cells. Melanin is just a protein that essentially gets injected into the keratin, into the hair, and it gives it its darker color. Now, there are a couple other components about the hair that you need to know about, especially if you're interested in reversing hair loss or reversing graying of hair. One of those components is a little gland. So next to every hair root within the dermal layer of the skin, so this is below the epidermis, there is a gland called the sebaceous gland. And the sebaceous gland makes oily stuff, and the oil is called sebum. I know the name sort of evokes something kind of gross, but sebum is actually really cool and really important. The sebum gets injected, or seeps rather, into the area right around the hair as the hair starts to approach the surface, where it goes from essentially root to shaft. And the sebum does two things. First of all, it forms a little bit of a seal right at the place where the hair exits the skin. And that seal is very important actually for waterproofing of your skin. So we don't often think of ourselves as waterproof because we are so accustomed to water just landing on our skin and rolling off. But that's because of some of the oily properties of our skin. Now, it's also true that our skin is pretty densely packed with cells. But in the absence of sebum, we would not be as waterproof as we are. Now, as I mentioned, sebum has two important properties. The other important property of sebum is that it actually is a strong antibacterial and antimicrobial. Most people don't realize this. The oils of your skin provide a lot of immune boundary so that things don't get into the hair root or the region around it, our skin. So sebum, while the name is sort of unattractive, to be honest, is actually performing some essential roles both for waterproofing and for our immune system function, protecting us from various kinds of infection. We're going to return to sebum later, because it turns out sebum is also very important as it relates to psoriasis and as it relates to some of the fungal components that can cause hair loss. Okay, so just going to file that away. There's another important component of the region around hairs, which is the erector pili muscle. The erector pili muscle is a muscle that lies diagonally between that bulb portion of the hair, or a little bit above it, and goes up to the surface of the skin. The erector pili muscle is a muscle that contracts when we get cold or when we get scared. So if you've ever had goosebumps, that's because the erector pili muscle contracts, pulling the skin at the surface down around the little hair follicles, or at least where the hairs meet the surface of the skin. And so those little bumps are actually where little micro hairs reside, and the dimples between them are the dimples that occur when this erector pili muscle pulls down. Now, why would this muscle exist? Well, it has a couple of important functions. One of the functions is that when it pulls down, it causes, as the name suggests, the hairs to stand up. Maybe not perfectly vertical, but when you hear, oh, I was so frightened, my hair stood up on end, and that's because the hairs become erect. They stand up. Now, why would this happen when we get cold? It happens because when the hairs stand up, air can be trapped between those hairs and can actually warm our body. This is not so much the case if you have very light hair on your skin. If you're a very hairy person, this is going to be a more robust aspect of your physiology. And yes, this is why dogs like huskies can go out in the snow and still remain warm. When they get cold, their hairs actually stand up a bit on end because of the contraction of these erector pili muscles, trapping air in there, and then their body warms the hair trapped beneath the hair. And it's sort of like they've got a blanket on made by the interface between the hair, the air, and their skin. So just to recap all the components of hair and the different things around it that are going to be relevant for understanding how to replace hair that's lost. We have the hair itself, which has the shaft that sticks out over the skin, goes a little bit into the skin, but basically sticks out over the skin. We have the root portion, which goes down into the skin. It goes through the epidermis and into the dermis. Then we have this bulb-like region down at the bottom. Down at the bottom of that bulb, we have stem cells that actually give rise to the actual hair, and we have pigmenting cells that pigment that hair. In addition, and this is very important, there are capillaries that go into that bulb region down at the bottom of the hair, and that can serve and support the stem cells, the melanin-producing cells, which are called melanocytes. So the melanin-producing cells and the stem cells get a lot of blood flow that allows them to keep providing new hair, or the proteins that make up hair, and the pigment that goes into those hairs. And those little capillaries deliver not just nutrients and things of that sort, but they also deliver oxygen, because it turns out that the whole process of growing more hair is a very active process. Now, as soon as you hear oxygen and you hear that the growth is an active process, that should cue you to why so many of the stories around how to keep your hair and regrow hair involve statements like, don't wear a hat, it'll make your hair fall out. Or if you want your hair to grow back, don't wear hats, or massage your scalp, or increase blood flow. Or why some people will suggest that people take peppermint oil, for instance, or menthol type oils of different kinds and massage them into the scalp, things that make the scalp tingle. Or there will be light therapies designed to what? To increase blood flow to the scalp. The whole rationale there is that you're trying to increase blood flow to the stem cell and the melanocyte populations that support the hairs and that actually create the hairs. Now, whether or not those approaches work, we'll touch on a little bit later. I'll just give you a little bit of a hint right now, which is that while no single one of those approaches that I described is known to regrow hair in a very robust way, because of the requirement for oxygen and nutrients, and because it's such an active process for the stem cells and melanocytes to grow and darken the hairs that grow out of your skin, it is true that manipulations or treatments that increase blood flow to those regions can at least slow the loss of hair, or can even extend the duration over which hairs continue to grow. So if you've heard things like don't wear a hat if you want to maintain your hair, or massage your scalp if you want your hair to grow faster, in some sense that's true, but none of those manipulations on their own is going to robustly enhance the rate of your hair growth. Those things are designed to be done in conjunction with some other treatments that have been shown in many, many clinical studies to increase the rate and duration of hair growth. So now you have in mind a picture